Hello to all. This is Ann Wagner with the Pacific Northwest National Laboratory. I'd like to welcome you to today's webinar, FEMP Re-tuning Challenge. It's brought to you by the Federal Energy Management Program, also known as FEMP. I'd like to share with you a few logistical items before we get started. First, a link to today's presentation was sent to all registrants earlier this week. The webinar is being recorded, and a follow-up email will be sent to all attendees with a link to the video. At this time, all participants are in listen-only mode. You may submit a question at any time during the webinar event by using the question pane on your computer. Questions will not be answered via the computer, but we'll be handling them live following the presentation as time allows. We will do our best to address as many questions as possible, and following the webinar, we will assemble a frequently asked question document, and we will share that with our registrants. Also, during the webcast, you can hit F5 on your keyboard to enlarge your view of the slides. Our presenters today include Niall Namir and Jay Roble from FEMP. Also Nick Fernandez and Dave Hunt, who are research staff at the Pacific Northwest National Laboratory, will be presenting. Our first speaker is Niall Namir. He's a program manager at the U.S. Department of Energy, FEMP. He has a wealth of knowledge in both facility requirements and energy conservation. He has worked for 3 different government agencies with 30 years of experience in facility design and construction. Also, we'll hear from Jay Roble, who is the manager of facility and fleet operations at the U.S. Department of Energy, FEMP, where his team supports federal agencies in meeting energy-related goals and implementing advanced technologies and practices. Jay has over 20 years experience in the energy and energy efficiency sectors. They'll be followed by Nick Fernandez, who's a research engineer at Pacific Northwest National Lab. He's been with us for over 10 years and has worked on a variety of projects, including building modeling, commercial building retuning, and self-correcting controls for HVA systems. Dave Hunt will follow. He has contributed to energy efficiency program activities at the Pacific Northwest National Laboratory for over 25 years. Dave currently supports the FEMP Operations and Maintenance Program. Prior to PNNL, Dave worked for federal agencies as a design and energy engineer. At this time, I'd like to hand it over to Niall, and he'll talk a bit about the Re-tuning Challenge webinar. Thank you so much.
Good morning, everyone. I want to welcome everybody to the challenge webinar. And what I'd like to do is in the next few slides go over some of the objectives and why FEMP is doing this webinar. So the objective of the webinar is, or for the retuning, is want to share with you how it's going to be done and build your capability, then train the trainer. That is the #1 goal for FEMP. Okay. We will discuss today why FEMP is sponsoring this challenge, what is retuning, and what is the next steps for you guys. Okay. Also, I wanted to talk to you about the working group that we are creating for the O&M. Like Ann said, I'm managing the O&M program for FEMP, and we would like to start up a new working group. I referred to it earlier to some of you in the presentations. as the problem-solving team. Okay. Okay. Why FEMP is sponsoring this challenge? Okay. Retuning is really an effective low-cost method for reducing energy. Okay. Retuning identifies the opportunities through the BAS system, or the building automation system. We have seen from previous retuning initiatives a savings between 5, and actually on your slide says 25, what we've seen higher than that, and I think we've reached 30% in some cases, of a simple payback, you know, from several months to 3.5 years payback. That's really very quick payback. We also would like to, you know, retuning is not a standalone initiative. It is part of an overall energy management program at your site. And we would like to discuss with you how the retuning fits in with your overall energy management, such as the ISO 50001 or the ISO 50001 Ready that DOE is sponsoring.
So this is Jay Roble from FEMP. I want to thank everyone for being on the call and to spend just a brief minute or two on the 50001 Ready program. For those who do not know, this is a US DOE created program, and the intent of today is not to basically go through all of this in detail, but to introduce it, because you'll see this as part of your questionnaire with regard to those sites who are interested in participation in the retuning challenge. At a high level, as Niall just said, you know, retuning is a part of active energy management or continuous improvement. And to help that process, DOE has created a recognition program around a structured energy management system. And we call that program 50001 Ready. The important thing to know about this is it's a no-cost program, and it's a DOE recognition for all sectors, manufacturing, commercial, federal, institutional. There is no certification or third-party audit requirement or a verification requirement as well. And basically, it's a DIY program, and at the same time, DOE offers a lot of technical assistance and tools, all free to end users. And we see a lot of application within the federal sectors, which is why we're trying to bring this program to market. Really what it is it's a repackaging of a lot of things that people are already doing if they're managing energy. And it's that repackaging in a way that fits the ISO 50001 structure. So we go to the next slide. Why this is important is because we've done a lot of research at the Department of Energy on the 50001 process. And what we found is that we have seen up to a doubling of energy performance improvement of facilities that have done 50001 versus those of their own that have not. So typically, if we look at energy use data, we see an energy intensity, we see about a 1% improvement nationally per year, industry leading about 2.5%. What we've seen through verified data is 5 or higher % per year improvement. The important part of that is most of that is O&M related savings, and things like retuning, retro commissioning, and just general basically O&M improvements have led to the savings that have been seen. So the program we've created is called 50001 Ready. It's basically 3 things. One is we ask folks to develop their 50001 plan. 2, we look at the energy data improvement. And then 3, we just ask for a self-attestation of conformance. At that point, then the U.S. Department of Energy will recognize the facility for being 50001 ready. Again, there's more information. If you go to the next slide, there's more information around the program. We're happy to talk to more people in depth later. This is a good example, though, from Tinker Air Force Base, who is 50001 ready. You know, to them, they found basically it's a way they change their internal processes just in a way to save additional energy. Also, one of the highlights is they basically view this as another way to apply their operational discipline, which is obviously something the military is very good at, towards managing energy, as well as the current things they operationalized as part of facilities. So again, this is nothing new. It's a repackaging of what you have, and we're hoping to get some involvement through the retuning challenge. So with that, I'll hand it back.
Thank you, Jay. So what is retuning? What is the retuning challenge? It's really a way to provide agencies with training and apply such training to their buildings in their portfolio. Sites can also participate even though they might not be selected. So even if a site is not selected, we're trying to arrange it for the sites that are selected that training can be offered at their sites. We will provide the following support for the selected sites. We will complete retuning of one of their buildings. We will train the staff, the site staff, and the staff that are attending from other sites as well. We will provide technical support for everyone. And finally, we will provide some results monitoring and presentation. The site participation, sites that are interested, they will be screened for retuning applicability. And Nick and others will actually provide you more details on that later on in the webinar. The selection will be made by June 27th, and the activity will include making an adjustment to HVAC system. It's basically at the BAS level of your facility. And with that, I'll turn it over to Nick.
This is Nick Fernandez. I manage PNNL's retuning program within the GSA portfolio. I'd like to start with an overview of retuning, and I'll do a deeper dive on some of the concepts and results from retuning in later slides. Retuning is a process of improving control of existing building energy systems centered on the BAS of centrally controlled buildings. It is part of a continuous improvement process for the building. The principles of retuning can be best understood by categorizing them in terms of one of the four sidebar principles on the right, which I'll get into later. In addition, retuning focuses on identification and correction of faulty control infrastructure, as well as adopting strategies for better monitoring and control into the culture and mindset of the building operators. For example, the use of trend data and training on how to manipulate the reset parameters that are implemented as part of the retuning process. Benefits of retuning have already been discussed a little bit by Niall, and these numbers do come from our experience and validation with GSA buildings, that most buildings fall within that 5 to 25% savings range and have that cost savings of 0.3 to 3.5 year payback period and 18.5 cents per square foot per year of cost savings. So this slide talks about the retuning methodology and how it's applied, and this is something that would probably be elaborated on a lot more within a training session. So this kind of gives you an idea of what to expect from the retuning training. So there are two complementary approaches to deploying retuning. A checklist approach helps to systematically identify which common approaches constitute relevant opportunities at the site. And then investigation and problem solving helps to uncover problems that may not be obvious while looking at the control sequences on the BAS. So for example, the plot on this slide shows an electric load that's intermittently turning on and off rapidly, perhaps indicating a chiller staging issue. In other cases, odd trend data behavior or unexpected load profiles can serve as symptoms of inefficient operations that need to be diagnosed through further investigation of the control and scheduling of building energy systems. So these are the sidebar principles that I'll get into that appeared on a couple slides ago. The first principle is called turn it off, wherein the idea is to identify energy systems that are operating when their services are not required at all. This includes AHUs, air handling units, and other scheduled HVAC systems whose schedules can be tightened, and in some cases utilize optimal start for a variable startup time, Other common systems include building lights if their schedules are controlled via the building automation system, snow melt systems, and garage ventilation and conditioning systems. Boilers and chillers can also be shut off based on outdoor air temperature to force the building into a single heating or cooling mode if the HVAC design and the occupancy characteristics of the building facilitate such lockouts. These lockouts often expose faulty sensors or actuators that require the locked out system to cover up otherwise poor conditioning. The second principle is to turn it down, meaning to take systems with variable operation set points and to tune them so that they consume as little energy as possible during part load conditions. The most common strategy is a reset, which is a form of feedback control that uses sensor data from the building or the outdoor conditions to intelligently change set points like fan static pressure, pump differential pressure, chilled water, hot water, and condenser water temperature. And another approach is night setback, which relaxes building thermostat set points during unoccupied hours. The third principle is mitigation of simultaneous heating and cooling. Building HVAC infrastructure is often composed of systems that have the potential to sequentially cool, then heat an airstream before it enters the zone. And it's not uncommon to encounter systems where the conditioned air may be sequentially heated, then cooled, then heated again under improper control. Two measures that can work in tandem to address these issues are supply air temperature reset and minimum VAV airflow set point reductions. In more complex systems, such as those with dedicated outdoor air systems feeding into conventional VAV air handlers, holistic management of set points throughout the chain is required. These set systems may also contain enthalpy wheels that in most cases save energy but can be operated inappropriately in ways that lead to simultaneous heating and cooling. At the zone level, tightly controlled thermostats can be a source of heating, then cooling, then heating, or heating in one zone with cooling in an adjacent zone and the air mixing in between. So widening the thermostat deadbands and or synchronizing zone set points can avoid these forms of energy waste. And finally, the fourth principle is to reduce infiltration in outdoor air, especially in hot or cold climates. Infiltration can be managed by addressing inappropriate or excessive use of exhaust systems and by using feedback to control air handling unit relief fans or dampers based on sensor measurements of building static pressure. Outdoor air introduced intentionally for ventilation can be minimized using CO2 sensors for demand control ventilation and by scheduling minimum outdoor air damper positions to 0 during unoccupied hours and reducing the position during occupied hours if ventilation is determined to be excessive. Okay, when formulating retuning recommendations, there are several principles that help to ensure success. The first is to stick to tried and true methodologies and best practices. One great resource on retuning measure sequences is ASHRAE. In particular, Stephen Taylor has written a series of essays on different retuning measures and how they are best implemented. In the absence of any experience at the building in varying set points, starting with standard minimum and maximum set points have been successful at other buildings is a good idea. For example, a range of 55 to 65 degrees Fahrenheit are good initial bounds to put on a supply air temperature reset. For some measures, there are a wide range of potential feedback variables. Again, it's good to choose feedback variables that have worked well in similar resets at other buildings. Finally, it's good to know when to apply different strategies for resets like trim and respond programming versus linear or span resets. So trim and respond is usually more effective when working with multiple feedback variables like zone dampers or zone cooling demands that feed into a single control variable, whereas linear resets are the clear choice when working with a single feedback variable like outdoor air temperature. A second principle is to pursue the path of least resistance. It is often the case that you can get 90% of the potential savings with, say, 20% of the work it would take to achieve all of the potential savings. And if there's a limited amount of time and money dedicated to the retuning effort, it's best to pursue a broad adoption of a range of measures that use a good strategy rather than to focus on perfect implementation of a single measure and leave a lot of opportunities on the table. In this light, it's best to incorporate into resets and other programming control points and feedback variables that are already being calculated at the building on the BAS and to tune, modify, or enhance existing resets if they're reasonably functionable rather than reinventing the wheel with a brand new strategy. Finally, choosing a sample of zones for feedback is often a good choice. For example, a hot water differential pressure reset might be formulated to use feedback from hot water coils but there are often several hundred coils in a building, and taking an average of a few dozen is probably a good enough approach. Other principles are to take into account observations of the baseline state of the building. What kind of set points have the building operators settled on for control of specific systems? Any reset of that variable should probably have a range that is inclusive of that value, unless there's evidence that the current set point is not a thoughtful choice. While on the same line, it's always smart to talk through the specifics of a recommendation with building operators to get their take and understand if there's any history or other in-house knowledge that would shed a light before finalizing a recommendation affecting multiple building systems. Okay, lastly, before finalizing a recommendation affecting multiple building systems, it's a good idea to perform a demonstration on one or more systems first. Besides validating the algorithm, it can help to inspire confidence and facilitate long-term adoption by the building operators. Okay, so this slide shows an example of the kind of recommendations that are provided as part of a retuning effort. The point of the slide is not to read through this text, but just to show that the recommendations have a narrative structure that describes a problem or opportunity within the baseline building and how it was investigated, and lays out a new sequence of operations that has sufficient detail to serve as a clear blueprint for a control contractor or for anyone at the building or organization who wants to understand the rationale and the details of the recommendation. So a couple of best practices discussed in the last slide are highlighted here, using investigation and problem solving, taking into account observations about the baseline state of the building, and then sticking to tried and true methodologies and best practices to initiate new control. So now I'll get into some of our experience with GSA in terms of the hard numbers for energy savings and the persistence of savings. So to give an idea of the expected results of retuning, the GSA portfolio really provides a large sample. Not only have we performed retuning at a large number of buildings, but we've also been responsible for determination of ongoing savings on an annual basis for years after the retuning effort at every site we visited. So I'll show two slides that shed light on energy savings results through time after retuning. This first slide shows the results of a cohort of 42 buildings for which we have annual savings data for at least 3 years after each site's retuning visit. So 2 sites had major occupancy reductions and they were excluded from the analysis, so we're trying to be honest here. Savings is broken into electricity in yellow, natural gas or steam in red, and then the total energy in gray. The aggregate savings was 9.2% in the first year and 12.9% in the second year, and that additional 3.7% savings in year 2 versus year 1 can be attributed to the fact that many sites take several months to a year to schedule the completion of the retuning measures that were identified and started during the retuning site visit. So the 12.9% is a good average for the ultimate savings potential from retuning from the GSA work. And then for year 3, the magnitude of savings we see is pretty similar to year 2 at 12.1%. And then finally, we have a smaller cohort of 25 buildings where we have 4 or more years of post-site visit savings. Overall, the savings is persisting into year 4. However, we have observed a handful of buildings that have showed some regression. And there are some important lessons to be learned from those buildings. There are 3 reasons we see for buildings that fail to maintain savings. And it's a small number of buildings. It's probably 10 to 15% of the buildings we visit will drop off the map in terms of their savings. So some of the reasons are, 1, certain buildings fail to maintain their control infrastructure, like sensors and actuators. And as those controls don't work as intended, the operations staff may start to override the automatic programming that was put in place. Second, there could be a change in maintenance staff, and the incoming staff are unfamiliar with the building's history and the retuning measures and how that was all put together. And so they override set points to control the building as they know how from their experience. And then third is, this has only happened once, but a default control sequences prior to the retuning effort may get restored following a controls upgrade or a power outage. So that's an important thing to try to avoid if you have a BAS upgrade. So the ideal retuning process would involve some kind of ongoing monitoring, maintenance of controls, and training of new staff to ensure persistence of savings. A few GSA regions with strong internal advocates for retuning have had the best success maintaining or improving the savings beyond year 3. This slide shows the actual achieved simple payback periods for the GSA portfolio. The graph plots the payback period against the building floor area on a log-log plot. The graph helps to reveal a strong correlation between the building floor area and the payback period. So basically, retuning scales very well, and we often achieve roughly the same savings in percentage terms, regardless of the size of the building. So larger buildings multiply the cost savings about linearly. Overall, among all GSA sites, the simple payback has been around 6 months, and 3/4 of the sites are below 3-year paybacks. This includes the total contracted costs for P&L, but it doesn't include additional costs borne by GSA, such as retaining a controls contractor to complete measures that we didn't complete on site. That can sometimes add another 20% to the costs. So keep that in mind. Okay, so now we'll get into the specific schedules and processes that we'll be following during the retuning challenge. This timeline is broken into 2 slides with 3 steps each. So the first step is the screening process, which we'll enter into in the weeks after this webinar. There are 2 stages to the screening. Candidate sites should first submit a screening questionnaire that addresses the basic requirements of the program by April 22nd. Then approved sites will be prompted to submit an evaluation questionnaire that addresses site suitability for retuning, so we can select the best candidate sites. That questionnaire is due May 28th. By June 27th, FEMP will announce the final site selection. After that process, the next step is a pre-site visit preparation for the selected sites that will include a pre-site visit coordination call and transfer of some preparation materials like interval meter data, trend data, and BAS screenshots to P&L. If you have the ability to give us remote read-only access to your BAS, then that can make the process a little easier. The site visits from P&L to the candidate sites will occur between the end of July through the end of the calendar year, and will include a retuning training session, identification and implementation of retuning measures. And then after P&L site visit, the building or agency will be responsible for completing implementation of the agreed upon measures at that building. P&L will provide complete documentation of findings, recommendations, implementation status, and action plans. And we will also initiate monitoring and verification of energy savings. After P&L's training of agency retuning representatives, those agency reps will also be responsible for identifying and retuning another site within their agency by January 24th, 2020. And so this is the train-the-trainer component that we want sites to demonstrate that they can take those lessons and move them forth on their own to retune their own buildings. Finally, a final report will be provided to each site and agency that compiles site feedback from the retuning process, highlights verified energy savings, and overall outcomes and lessons learned. This slide is a bit of a deeper dive into what the site visit will look like, kind of breaking it down by day. So expect a 3 to 4 day site visit. The first day would be a presentation training session for agency representatives who will be involved in the future internal retuning effort at their other building. And then a building walkthrough with the operations and maintenance staff, building management, and those same agency representatives. So it's still part of the training, the walkthrough. And then day 2 is a BAS review and interactive training session. So we'll be looking to identify retuning measures and formulate the recommendations, and it'll be an ongoing dialogue. So it'll be also part of the training process. We like to still have those agency representatives there on day 2. So it will require your O&M staff to be present and to discuss those measures with them and any conflicts and limitations that we should be aware of that will help us to better formulate those recommendations. And then we may have some potential demonstration or testing of some of the measures occur on day 2. Day 3 and 4 will be continued implementation of agreed upon retuning measures. In some cases, this may require a retention of a controls contractor paid for by the agency who is familiar with the building and the BAS programming. Finally, after the visit, the controls contractor may need to return to complete those measures. Again, that would be paid for by the agency. So this is a list of the list of some of the characteristics of good buildings. So these are things to kind of look for as you're deciding which sites to submit for the challenge in the level 2 screening. So we're looking for large buildings, at least 100,000 square feet, but ideally something even larger, let's say 300,000 square feet. As I mentioned, the retuning process scales well, so that would lead to higher cost savings. Sites with high baseline energy consumption relative to similar buildings and similar climates are good indications, especially if you don't have an explanation of why the energy is higher. You know, if it's not a mission critical 24/7 building, but it still has high energy consumption, that's maybe something to look at. Buildings that have digital controllers, actuators, and thermostats give us the best opportunity to implement the kind of retuning measures that we typically implement. We're looking for buildings with a modern BAS, ideally updated within the past 5 to 8 years. A BAS with control of systems like chillers, boilers, and lighting systems. Buildings with substantial penetration of variable speed drives into their pumps and fans. Buildings with single duct rather than dual duct air handling unit. Presence of dedicated outdoor air handling systems provide extra complexity that often reveals some opportunities for savings. We're not really looking as much for mission critical buildings because it's often hard to agree to retuning changes at the building if there's if energy is not as important as the mission of the building. And then we're also looking for buildings that have little to no previous attempt at retuning or control-centered energy savings projects. We don't want to be picking the highest hanging fruit from the tree, so to speak. Oh, and then one more thing: the site should have an active energy plan in place.
Thank you, Nick. This is Dave Hunt, and I'm here to take you now through the end stages of this. What your next steps are. Before going into that, I'd like to go over a couple items. First of all, we're scheduled to run through the top of the hour, which gives us some time. If we happen to run over the top of the hour, we will have time because we want to address all the questions that we receive. And if you have to leave, as Ann noted at the beginning of the call, we will be sending out frequently asked questions and responses to those. So you will have available to you all the questions and answers. And with that also as a reminder that if you have a question, please use the question pane located on the panel on your screen. So far, what we've discussed today, there was an introduction to retuning. Nick talked you through how retuning is addressed and characteristics of the buildings and the expectations of participants in the challenge. There is also an introduction to 50,001 Ready. And in your slides, there are links for you to obtain more information on 50,001 Ready. What we're going to discuss now, though, are what are you going to do with this information? If you're interested in participating in the retuning challenge, the first thing you need to do for your site is determine that there is indeed an interest to participate. And by an interest to participate, that would include your site is willing to implement identified measures, that your site staff will participate in the training that is offered to them, and that those staff will then proceed to, under P&L supervision or assistance, to do a retuning of an agency building on their own, and that those results will be shared then as a part of the retuning challenge outreach effort later on. Other factors that would, those criteria are identified in the screening questionnaire that was sent out preceding this challenge. The screening questionnaire that was sent out then is due to the submission information is due on April 22nd. And the instructions for those submissions is on the screening questionnaires themselves. We've mentioned that there will be two questionnaires in this process for the sites that meet the criteria that are presented in the first screening questionnaire. We will ask you then to submit the subsequent evaluation questionnaire. That will likely come to you in early May, and those would then be completed evaluation questionnaires would be submitted at the end of May. Within the screening questionnaire, some items that we'd like to highlight are we're asking for general information on the site. We're asking for some identification information on the staff that will participate along the way. But included in there are some hard criteria that are identified here. The first of which is that the building does have an HVAC system that is controlled by a centralized building automation system. The second being that metered data for that building is available. That would be interval metered data. Ideally, it would be a site meter. It could also be a utility meter, but we'd have to be able to access the data. And then the third criteria are the commitment of the site to, as mentioned before, to implement the identified measures, participate in training, and to then use the trained staff to retune another site or agency building. A part of this effort is we will look for or be interested in sites that are able to host personnel from other sites as a part of the on-site training. And also, we will be interested in working with sites that are in the process of or have already implemented 50,001 ready. So today is the kickoff, the official kickoff of the retuning challenge. We've shared the information, and the key date on here is April 22nd. That's when your screening questionnaires are due back to us, and then the subsequent evaluation questionnaire, if you're asked to provide that, will be at the end of May. And FEMP is targeting site selection, final site selection by the end of June. And Nick presented the other milestones along the way that will involve the P&L working with your site. So the takeaways and the next steps are to please look at your site and determine if you're willing to make the commitment to the retuning challenge, and if you are, submit those completed screening questionnaires to us. If you're looking for additional information on building retuning, what is it? What are the principles? There is some detailed information available at the website buildingretuning.pnl.gov. If you have any questions on the retuning challenge, please forward those or submit those questions to FEMP Re-tuning Challenge at pnl.gov. And if you'd like to talk to Niall, the mayor, the program manager for O&M and the retuning challenge's contact information is available here as well. So with that, we've completed the presentation portion and we're ready to move on to the question and answers.
Thank you all very much. Niall, Jay, Dave, Nick, you've really great information here. We have received quite a few questions about the challenge. As I mentioned before, We'll be addressing them at this time, and we will also be following up with a frequently asked questions document. If we do not get to your question because of limited time, then we intend to include it on the FAQ. Also, don't forget there is the question pane if you have not submitted questions yet, and I have several questions here that I'm going to be asking, so if you'll bear with me. All right, my first question is regarding the 50,001 ready, and it asks, is 50,001 ready a requirement to participate in the challenge? And I'll let Niall answer that one.
While it's not a requirement to participate in the challenge or for the sites to be selected, retuning should not be, it's not the answer to everything. It should be part of your overall energy management program. And the 50,001 ready gives you a great architecture for having a very successful energy management program. We've seen a lot of savings even for active energy management programs. When they incorporate the 50,001, they actually realized even more saving. So it is not a requirement, but it is preferred by FEMP to have that. And we'd be happy to provide more training and support. We understand that some of you this might be the first time they heard about the 50,001. We'll be happy to provide you training and support on that.
Great, thank you, Niall. Also, I did make a note of my own during the presentation, and Nick gave good information about GSA as an example. Also, our retuning team has worked quite a bit with the Army and have seen very similar results. So wanted to let you know that we've worked with various agencies and have seen consistent results and some similarities. So we're finding out about commercial type buildings and such. What a surprise, maybe not. My next question regards how does retuning differ from retro commissioning? And I'm going to let Dave Hunt answer that one, please.
Thank you, Ann. The retro commissioning and recommissioning can encompass a lot of procedures. They may address HVAC, lighting, other control systems, water, or even envelope systems. And when we hear of recommissioning, we tend to think of that in terms of functional testing, making sure all the equipment is working correctly. Not all buildings need all that level of commissioning, and there may be cases where buildings really need to have a recommissioning type focus on the control systems. And in those cases, that's where retuning is good or applicable. So think of retuning as a subset of and retro commissioning that to consider when you have building automation systems.
Thank you, Dave. I have another question here. It looks like it's for Nick. And the question is, will the retuning activity involve making adjustments to the HVAC system?
Yes, absolutely it will. And as a follow-on thought to that, because we are making adjustments to the HVAC system, it is really critical that at least a vast majority of the systems and components, the FDs, sensors, actuators, must be in proper working order. So we really don't want to encounter the situation where we visit a building where the sensors aren't reliable and things are overridden and things like that because they haven't been commissioned.
Thank you. I have another one here for Nick, and it's asking, does the audit include looking at water?
We will look at water in the event that there's really good meter data for water. So in particular, we're looking for interval meter data at least the hourly level, and that gives us the kind of data that we would need to identify any problems or opportunities.
Okay, thank you. Actually, I have several questions, and I'm going to kind of make sure we cover them here that regarding ownership, who's managing, things like that. So one of the questions is worded, I think, very helpfully, which is, do buildings need to be federally owned as opposed to leased? I'm going to give you a little bit more on that one too, because there are some various as far as ownership, and I think the answer probably addresses also as far as who's managing the building. I guess, if Dave, would you like to speak about what makes a site eligible?
So there can actually be a number of arrangements regarding ownership. The key here is that the federal agency realizes the cost savings from retuning. So if the federal site owns the building and is paying the utilities, then clearly they would receive the benefit from the energy savings. The other case would be a leased building and a fully serviced lease where utilities are paid unless there's a way to get some sort of equal lease payment consideration, and the answer is no, the government wouldn't receive the benefit and the site would not be eligible. But if they're in a lease arrangement where the government is paying the utility bill, then yes, that site would be eligible.
Okay, thank you, Dave. I've got one here, and it's asking about active energy plan. It says, could you elaborate on the requirement about an active energy plan? And I'll go ahead and let Niall handle that.
You know, we've been talking about the overall energy management plan for a site, and again, retuning is a part of that. It's not the answer for everything, but it is a good opportunity. Now, Jay talked to you guys about the 50,001 energy management program and the recognition by DOE. Again, I understand that a lot of you may not be familiar with the 50,001, and I want to renew my offer that would be happy to provide training and support, walk you through the 50,001. I suspect most of these sites are probably about 80 to 85% there, if not higher. It just formalizes that energy management plan. Would be happy to provide more training on this and maybe set up like a call or a webinar to talk about the 50,001. And again, the recognition by the Department of Energy for sites that have incorporated that certification is not required, but there is a recognition that we can provide to sites who adopt the 50,001 ready.
Thank you. I have another one here for Nick, and it is, do you require remote access to the BAS?
No, that is not a requirement. It's something that can make everyone's lives easier. Otherwise, it becomes a bit of an iterative process where we have to get a representative from the site to get us the data we need, and so it just requires a little more back and forth by email, but it's not a requirement, no.
And also for Nick, how deep do you get into the programming of the BAS, or will you just look at set points, setbacks, etc.?
We do get into deeper into the programming, and it's why we often will require a BAS contractor, especially if it's an uncommon BAS that we don't have in-house expertise in programming with. For certain BAS systems, we do have in-house expertise. For the common systems like JCI and Niagara.
All right. I've got another one for Nick. When implementing multiple new reset strategies for a building, how do you determine which is the most effective, and how do you structure the programming to prevent different strategies from competing in the negative feedback loop?
Well, it's kind of a building-specific determination of which one's going to be more effective, and there's no easy answer to that part of it. I think on the question of competing measures. So the example that comes to mind for me is supplier temperature reset and static pressure reset can be two resets that affect the amount of cooling that's delivered to a zone, and so there may be the potential for those to compete with each other. The best way to avoid them getting into any kind of competition is to just use different feedback variables for those two resets if they're both being implemented. And then there are sequences that you see where the same feedback variable is used, and in that case there's sort of a staging approach where you require a higher threshold for the same variable to go into the next one. So for example, static pressure reset might be the first stage for a 30% average cooling demand, and then as you get up to 50%, then you start to do supplier temperature reset or something of that nature. But generally, we use different feedback variables for anything that might compete, but it's not very common that you run into that.
Okay, thank you. I've got another question here, and it is asking, is there only one retune study available per federal agency?
Okay, so the question then
and I was
is,
going to give it to Dave.
Yeah, I think the question is, might more than one site be selected for a federal agency? That's why you're that question. And so the sites are being selected. Yeah, there will be a limited number of sites, and they're going to be selected on the sites that present the best opportunities, not only for retuning, but also reaching out to within that agency and the local agencies that are able to participate in training. And now, would you like to follow along with that?
Yeah, I mean, the part of the preference, again, what FEMP is trying to do with this is not just retune one or two facilities at each site and walk away and we're done. It's to provide the maximum outreach to the federal agencies. So as we select sites and we look at those sites, the ability for that site to host other agencies, especially in their local area, even if a site decides to travel to participate, and that would be looked at highly, and we would prefer that. So we're trying through this is to come up with, again, not just retuning the facilities, but ways to retune, training, education, and pass that on to all agencies, whether their sites were selected or not.
Okay, I've got a question here, and it says, if meters are installed but not working on a site, can your team help with troubleshooting broken meters? And I would say this is beyond the scope of the retuning challenge. So we'd love to help you. Unfortunately, that's not covered by this particular activity at this time. But we do want data. Another question had been, does the site need to provide the interval data, or can they fill out the form so that the retuning team can get the interval data from the utility? And I don't know.
Yeah, if there's a process by which we can gain access, we're happy to do any legwork on our end to get the interval data.
I mean, you're after the data.
Yeah,
it comes.
However it comes, it's not a big.
Okay, well, we have come up on the hour, and we've gone just a smidge over. I do know that Niall would like to make an additional comment, and I believe that will be it. Thank you very much for joining, and I'll give it to Niall.
Okay, I just want to emphasize one thing. We're not after highlighting negative things at each site or at the site that participate. We're after the positive. We want to make sure that, you know, lessons learned and success stories are passed to other agencies. We don't really care about, even identifying the agency. So if an agency has an issue, we might just not even mention that agency. So again, we're interested in making a difference across the government, across the federal agencies. So as sites participate, we will be very sensitive to their concerns, and we will try to address those concerns in a satisfactory manner to them. And with that, I think this concludes the webinar, and I really want to thank everybody for participating. And we provided earlier the points of contact for this webinar, and the whether it's the retuning or the 50,001. Please take advantage of those, and thank you very much for participating.